Alright, we're going to take a look at bubble sort, quick sort, and merge sort. Sorting techniques are very important to computer science and programming in general. These algorithms help you sort lists and various numbers quite effectively and efficiently, so it's kind of important that you learn all about sorting. So let's take a look at the first one, which is bubble sort. Now, here we have an array of 5, 1, 4, 2, and 8. And we're going to sort the list from lowest to highest. And bubble sort is a fun sort to say, bubble sort. um, and it kind of, but it's also one of the most not used ones too much because of how ineffective it is compared to, say, quick sort or merge sort. But I like bubble sort, and it's an effective sorting technique. So let's take a look at it. The First we have that list of 51428, and you'll notice that it has several passes in this sort. And what it does is that it sorts it by passes, and on the final pass, if it realizes that the list is actually sorted on the last pass by not making any swaps, then the bubble sort finishes. Okay, so it'll do several passes, and then on the last pass, once it's sorted, it realizes it needs to stop at that point. So that's the beginning and the end of bubble sort. So let's take a look at it. Here's the first pass. It's going to start from the first digit right here, which is number 5, and it's going to compare it to the next digit right next to it, which is 1. 5 is greater than 1. So on the first pass here, it's going to swap 5 and 1 right here. Now, at that point, since it's swapped the 5 and 1 on the first pass, it's going to continue moving on with number 5. And then compare it to the next element next to it, which is 4. 5 is greater than 4, so it's going to now swap that. Now, since it's swapped 5 and 4, it's now going to compare 5 with 2 in the same pass here. And 5 is greater than 2, so it's going to swap that. Finally, 5 and 8 needs to be compared. These elements are already in order, so the algorithm doesn't swap them. And that's the end of the numbers in the list here, so it stops. Now it completes the pass. Now the second pass, it'll start from the beginning again. 1 and 4 does not need to be swapped because 1 is less than 4, so it doesn't swap them. So since it doesn't swap them, it now moves to the next element, which is 4. So remember up here, it kept on swapping it back and forth, so therefore it stayed with the 5 until it found a place for it, which was right before 8. But then it was the end of the pass, so it now started the second pass. Now 1, it found its place because it's not greater than 4, so therefore it leaves it there and then bubbles up and moves over to 4. So now 4 is now comparing it with 2. These swap, so it stays with 4. 4 compares itself with 5. It notices that it doesn't need to be swapped, so therefore it moves the bubbles over to 5, which is the next element in the list, and then it does not need to. It does the comparison, but it doesn't need to be swapped. So therefore, but now it's at the end of the list, so the second pass is complete. All right. So now for the third pass. Now remember, this list is in order. You could see that right now, but the bubble sort does not know it's done. So it'll still do another pass. Now 1 compared with 2, it stays. It moves over to 2. So 2 compares itself with 4. It stays, so therefore it moves over to 4. 4 compares itself with 5. It stays, so it moves over to 5, and 5 compares itself with 8. It stays. So therefore now it's at the end of the pass. But now, since the algorithm realizes they didn't make any swaps in the third pass, it knows that the bubble sort has been completed. So therefore, it now stops the bubble sort. Okay, kind of a simple way of looking at sorting. The other ones become a little bit more complicated algorithms, but bubble sort is pretty straightforward. Now, if you look at this little video I have here, it actually shows you, a fun way. I found this little video online, and it actually simulates the bubble sort with this list right here. So let's play the video and watch it sort. 6 and 5. It's going to do a swap. Now it's going to compare 6 and 3. It's going to do a swap. Now it's going to stay with the 6 and 1. It's going to do a swap because there's still, and now since we're swapping, we're still going to compare 6 and 8. It stays. So now we're going to compare 8 and 7. 8 and 7 swap. So now we're going to stay with 8. 8 and 2 will swap. So we're going to still stay with 8. 8 and 4 will swap. So, and we're at the end of the list. So, and that's the first pass. Now we have to do the second pass. 5 and 3 will swap. So therefore we're going to stay with the 5. 5 and 1 will swap. So we're going to stay with the 5. 5 and 6 will stay. So therefore we will, since 5 and 6 are the same, it's going to stay, it's going to now change to the 6 on the next pass. So now 6 and 7 need to be passed, and then it skips that to 7 and 2. Now 7 and 2 will swap. Now 7 and 4 will swap. And 7 and 8 will still remain the same, ending the pass right there at the end of the list and start from the beginning again. So as we could see, it's going to keep on swapping, and then if it swaps, it's going to stay with the element. And if it doesn't swap, it's going to move on to the next element here as we keep on going through the different swapping stages here. And it takes a little bit long for the sorting to continue and get into the right order. As you can see here, it's almost done. Let's see here. 3 and 5 still. Okay, 2 and 5 need to swap now. And then 5 and 4 will swap. And the rest of the list is fine, so it'll stay as it is. It's actually still performing the test, but the simulation, but it's kind of skipping through it. So there we go. It's 1 and 2 and 3. 3 and 4 is fine. Okay, now we're finally to the last pass here. It'll notice it doesn't need to swap anything. It doesn't swap anything, so therefore it is now complete as it's testing it all the way through. And there we go. And that was bubble sort. And hopefully that was helpful for you to watch that and go through the steps of bubble sort. The next one we're going to look at is merge sort. And so this merge sort, it's going to take a list right here, 38, 27, 43, 3, 9, 82, and 10. And what you need to know about it, it's just going to break it off until it becomes single elements. So this first part right here, it's going to break it off until it becomes single elements all the way across. Then after that, it's going to merge into sub-lists in which form back into one giant list again, but this time it's sorted. So let's take a look at how it does that. The first thing it'll do is these single elements need to be turned into a list of 2 afterwards. So it's going to go compare 38 with 27, and it's going to go 27 and 38. After that, it's going to do another list of 43 and 3. It's going to go with 3 and 43, 9 and 82. And then since this doesn't have a pair, it just drops down again for the next row with just one element with the number 10 in it. Now that it's done grouping of 2, it's now going to do the group of 4 with these two lists of 2 elements each. So it's going to do the first pass of 27 compared with 3, which is 3 is going to go first, and then 27, 43, which then 27 drops. Then it goes to the second element, 38, and, well, nothing, because 3 and 40, no, wait, 43 didn't get dropped yet. So 27 and 3 got dropped, 27 and 43, 27 got dropped. Now we move on to 38, 3 has already been gone, so 3 and 43 compares, 38 gets dropped, then there's nothing left in here, there's only 43 left in here, so that drops into that list right there. Then the next sub list over here, 9 and 82 and 10, so 9 gets compared with 10, 9 drops. 82 now gets compared with 10, 10 drops, and then 82 is left over, so 82 gets applied here. Now we're going from a list of 4 to the supposedly a list of 8, but we won't have 8 because this will only have 3, and so a list of 7. It'll be the final list. So now 3 gets compared with 9, 3 drops, and 3 compares with 9, 3 drops, 27 gets compared with 9, and 27 with 27 obviously is greater than 9, and 9 drops. So, and then 27 and 10 drops, 27 and 82, 27, 38 and 82, 38 drops, 43 and 82, 43 drops, and then 82 is left over, so 82 drops. And that's how you get the merge sort at the end right here. And then the last sort was really difficult to follow as you're comparing each element across each time by the index. So that gets a little confusing. So we're going to watch the video right here, merge sort, of another simulation that I found. And it shows you the elements being highlighted in red and which ones are being compared to, like we get to the part right here. So let's take a look. It's going to break it up first of all to single elements. There we go. Now 5 and 6 is going to be 5 and 6. 1 and 3 is going to follow. 7 and 8 is going to follow. 2 and 4 is going to follow after that. Now 5 and 1, 1's going to calm down. 5 and 3, 3's going to come down. 5 follows, 6 follows. 7 and 2, 2's going to come down. 7 and 4, 4's going to come down. 7 drops, then 8 drops. 1 and 2, 1's going to come down. 3 and 2, 2's going to drop down. 3 and 4, 3's going to drop down, then 4. 5 and 7, 5's going to drop down. 6 and 7, 6 is going to drop down. 7, then 8. That last part ran a little fast, so you might want to slow down the video when you get to this point, because that was, as you could see, the elements were comparing with each other as we were going really fast. I couldn't even keep up with talking as fast as the simulation was going. So hopefully that helps you understand the merge sort. Now we're going to move on to another sort. And that other sort's going to be quick sort. See there. Quick sort. Start that from the beginning. I'm going to kind of maximize this as much as I can here. Oh, that's a little bit crazy. All right, so we're going to start off with this list right here: 1, 12, 5, 26, 7, 14, 3, 7, and 2. And what are you going to do in quicksort is you're actually going to find a pivot value, an I value, and a J value. And you're going to move them around until the sort has a list in order. Now the pivot value could be anything you want. It's just a random element that you pick, and what you're going to do is you're going to sort the list based on the pivot value. If it's going to be less than the pivot value, or greater than the pivot value, or equal to the pivot value. Now the elements to the left of the pivot value is going to be less than the pivot, and the elements to the right of the pivot value are going to be greater than the pivot value. And the ones that are equal could either be to the right or left. Most people prefer to put it to the left of the pivot value. It seems to run faster. Well, not really faster, but logically it seems to make better sense to most people. So let's take a look. Here's the original list. It's unsorted. We chose a pivot value of 7. Now, here's where you place the I and J. The I will go into the first element. The J will represent the last element. And we're going to move the I and J accordingly with the value of the pivot. So let's take a look. You'll see that the I value is 1 and the J value is 2. The I value 1 is less than 7, so there's no swapping that will occur. So therefore, if there's no swapping because I is still less than 7, we'll move the I value to 12. Right there. We won't move J yet because we haven't done any swapping. Now, I is now representing 12, J is now representing 2. The pivot value is still 7. So 12 is greater than 7, and 2 is less than 7. So we're going to do a swap right here of 12 and 2, which on the next line you could see 2 is there and 12 is there. So now the I value will move over to 5, and J will get moved up to 7. Okay. Now 5, remember the pivot value is 7. 5 is less than 7, so we need to move up I. So I gets moved up to 26 because I is already less than 7. 5 is less than 7. So I gets moved up to 26, and now we're comparing 26 is greater than 7. Look at the J value, 7, they're equal, right? 7 is equal to 7, which means you could swap it to the other side of 7 right here. So we swap 26 and 7, you get 7 here and 26 on the other side. I and J get moved up. J gets moved to 3, I gets moved up to 7, which is where the pivot is, actually, right there. So 7 and 3, 7 is equal to 7. Okay, so remember, like I said, you can move it to the right and left of 7, so therefore this can be swapped. And 3 is less than 7, so these two will swap. Okay, so it gets moved over to this side, 3 over here, 7 on this side. I got moved up to 14. Now, at that point, when I gets moved up to 14 and it got swapped, I is greater than J. So stop the partition at that point. Once you stop this partition, you're now going to have where these two crossed over, and I is now greater than J, stop the partition, you're going to have these two lists right here, 14, 7, 26, 12, 1, 2, 5, 7, and 3. And now you have to run this recursively, and do another quick sort on this, and a quick sort on that, and you keep on sorting all the elements until you have a list that is completely sorted all the way across. So you'll break it up, and now you'll have to do, that's why merge sort is kind of interesting because you'll merge this sort all back together again once you run the quick sort and break it up. So that's how you can see merge sort applying to quick sort right here at the end. So with that in mind, let's go ahead and look at the quick sort video and run that. 65318724. It's going to pick a pivot of 3. These two, 6 is greater than 3, 4. They're going to do a swap right there. 2 and 6, 5 and 7, 8 and 7, 1 and 3, 1 and 5, sorry. They're going to do a swap right there, and then it's going to move to the 3. All the elements to the left of the quick sort are now less than 3, and all the elements to the right of the pivot are greater than 3 right there. You're sorting the left list of the pivot right now, and now we're going to be sorting the right side of the pivot now. 4 and 5 are going to swap. 8 and 6, 8 and 7 are going to swap. Oh, they didn't. What was the pivot? 4? Stop that and figure it out right there. The pivot now is 6, 5 and 8. Left 5's could be less than 6 and 8 is greater than 6. Now you're comparing the pivot and actually number 7. They're going to swap right there. So these are the elements that were already ordered. 5 and 6 are going to stay the same. 7 and 8 are going to stay the same. And there you go. That's quick sort. The list is finally sorted. Right? But hopefully this video was helpful. You could watch the simulation over and over again, like I said, get a better idea, and see that PNG file that I have there of quicksort. Thank you, and I'll see you in the next video.